So I think, well, what do you predict? Would we see a precipitate or not?
We're rolling.
Okay, so we're predicting that we're not going to see a precipitate happen here because our solubility rules predict that copper iodide is soluble in water and potassium nitrate is soluble in water. So shouldn't see a precipitate happen. So Lily's going to mix those two in an empty well and straight up and down. It's okay.
Did it go into drop?
Oh, I thought it did.
That one was close.
I should just get the bin so I don't throw everything. Okay, that's why we wear goggles.
I'm just trying.
Fun. All right, go ahead and drip in there and then go wash your hands. What was that?
Not the
Potassium
moderately
iodide.
toxic one.
It's potassium iodide.
It's not so bad.
I don't think you got on my hands. Should we still wash them? It just splashed on the table.
Yes. So I see a precipitate. Clearly, that is here. Take that and head to the bathroom. There is a precipitate, but I'm pretty sure we've got some kind of contamination here because it like poofed everywhere, and I'm going to try that again. I think that
It's broken.
and that is just, it's got to be contamination. Huh. It's precipitating every time. Copper iodide. And I'm baffled. I don't know. We got it happen twice. Alright, let's wipe off the table. And it's always fun to try to think of what in the world could have happened to cause this error, some kind of error. Alright, let me look at the rules and just make sure. I don't see any reason that there should be a precipitate there. But clearly we observe a precipitate. So if you were going to decide which of these precipitated, would you pick copper iodide or potassium nitrate?
Copper iodide.
I would too. Nitrates are definitely very soluble.
So do we put that one as solid? Or?
I'm underlining it for now. And when we use, I think the potassium iodide, because it's the one that like was exciting. There's a precipitate there. I don't know.
So what about
We might have to revisit that one. Oh, it's always fun to have error. Okay, so let's do the next one and see what we think. So we've got copper nitrate and sodium hydroxide. So what do we predict about those two products? So copper hydroxide, if we look at rule 7, what do we think?
There will be something because hydroxides are insoluble.
Right. So unless it's a strong base, we think hydroxides are insoluble. So I would predict copper hydroxide is going to be a solid. How about sodium nitrate? We've already looked at sodium nitrate. Yes, sodium nitrate has shown itself to be pretty soluble. This is just so strange. I wonder. I'm going to do that one more time in a center well, because we use those edge wells and I wash them out. But the center ones I almost never use for anything. I wonder if we just have serious need a new well plate. Yeah, it precipitated. I don't know. I have to look that up. I'm surprised. All right, so Saul's going to mix copper hydroxide and sodium, or no, he's going to make that. He's going to mix copper nitrate and sodium hydroxide. There's copper nitrate. So don't use these two wells because when that bottle opened, it like splashed. So just pick one far away from the splashing, straight up and down. Okay, so we've got copper nitrate. We've got, not that one, sodium hydroxide. We think we'll get a precipitate. Oh, watch. See it darkening a bit? So that's harder to see.
Anything.
Can you see like the
Yeah, I can
streakiness in
already
it?
see. Yeah.
It's harder to see, but when you put it on white,
Looks like cloudy.
woo, that could be exciting. Don't sneeze with well plate in hand. Plus, we need to look at that one. Now we're starting to see, can you see the blue one has a little precipitate? I'm just going to stop walking with the camera. Also, this first one that we did, where we weren't sure about calcium hydroxide because it's slightly soluble. Now, if we look at the first one, can you see that it's a bit cloudy? So we see just a little precipitate. And with the blue, you can see just a little bit of stringy.
What's the orange?
That's the one that we had the failure over there with. I don't think that we should have seen a precipitate, so we tried it 3 times. Copper or iodide would be, I mean, I know potassium nitrate's not going to precipitate, but this blue one is the one we just did, and you can see the kind of thready dark blue precipitate.
Yeah, I can see stuff.
And then this first one that we did, where we weren't sure if calcium hydroxide was going to, it's just a tiny bit cloudy. So you can tell the difference there between slightly soluble and
So do we put solid for that one?
I think so. There's a little precipitate, and then you can see the precipitate, that stringy dark blue stuff in there. So there's definitely a little precipitate going on in there. So I think that we're looking at this being a solid now. That definitely precipitated a little bit of dark blue stuff. And now we're going to look at Jolene with copper nitrate and sodium oxalate. So that will produce copper oxalate and sodium nitrate. Now we've looked at sodium nitrate a bunch of times. We know that is going to be soluble. We also don't have a rule for oxalate, but we saw that calcium oxalate was a precipitate. I'm going to say it's likely that copper oxalate is also going to be a precipitate. I would say if you had a rule for oxalate, it would be insoluble. So, copper nitrate, sodium oxalate. So pick a empty well far away from the others. Oh, we lost the bottom. Okay. So she mixed copper nitrate and sodium oxalate. Not filming. Okay, so we see definitely a nice little, yes, if you got some on your hand, go ahead. We see a pretty light blue precipitate there from that, which would be the copper, the copper oxalate. Not walking around. So this light blue one is our precipitate this time.
So the copper oxalate would be a solid.
the copper oxalate as the solid, and then still dissolved in the solution we have the sodium nitrate. So next we're going to mix lead nitrate, which really you're going to want to wash your hands if you get lead nitrate on yourself, and potassium iodide.
Okay, so that last one was solid.
Yes, we got a precipitate that was copper oxalate. Lead. Oops. Lead. Yeah. Potassium iodide. This we already did once. And you guys saw it once before. So 1 or 2 drops of each in the same well.
I don't get to
Any well you like. Oh, did I skip you?
Yes.
Sorry. I'll let you do the next one.
You skipped me.
I skipped you. So,
That is a very scary looking color though.
whoop, there we are. You don't have to put any more. We definitely got a precipitate there. So we mix 2 clear colorless liquids. Grace washes hands because that's lead. And we get beautiful yellow precipitate. So which thing is the yellow precipitate? We saw this at the beginning of the year. It is cool looking. You can see why lead paint was popular once upon a time because it makes such beautiful, vibrant colors. So, potassium nitrate or lead iodide as a precipitate?
Lead iodide.
Lead iodide. We've already seen that potassium nitrate is soluble. And if we look at our rules, Rule 4 tells us all chlorides, bromides, and iodides are soluble except silver, lead, and mercury. So we can tell that lead iodide is not soluble based on Rule 4. So Jenny, let's go. So we've got lead nitrate and sodium hydroxide. So let's predict lead hydroxide or sodium nitrate. Are either of those going to be insoluble? Right. Lead hydroxide is not a strong base, and according to Rule 7, all hydroxides are insoluble except row 1A, strontium and barium. And lead's none of those, so I would predict that we're going to get a precipitate out of lead hydroxide, and that this, of course, sodium nitrate is going to be aqueous. So we're mixing lead nitrate and sodium hydroxide, Jenny. Lead nitrate.
And I'm going to wash my hands.
Not if you don't get any on you. But yes. Is that the lead? Don't get it on your eraser. You'll be needing lead into your artwork for years to come. Oh, it is dripping everywhere. Hold real still. Nope. Lift. I don't want to contaminate every well with it, so let me just... Okay. Straight up and down. 2 drops. Good. Of course, this is qualitative, not quantitative. We're not too worried about how much. We just want to see a precipitate. So put in the sodium hydroxide in the same well. We think we'll get a precipitate. Straight up and down. Don't touch the edge to the thing and contaminate it. Okay, that's enough. We saw it. So definitely a precipitate is white lead hydroxide. Same white precipitate we keep seeing. That's my kid. Oh. Okay, so
I'm fine.
probably I'm fine. So now we've got lead nitrate mixed with sodium oxalate, lead oxalate, and sodium nitrate. Once again, we know in the next two situations, this sodium nitrate is soluble. So when we make lead oxalate, lead things aren't real soluble, oxalate things aren't real soluble. I'd take a pretty good guess that lead oxalate's not going to be soluble. But we don't have a rule for that, so let's find out. Haha. So pick a empty well that doesn't look contaminated. I'm just throwing out this well plate. Now you can buy like 6 well plates on Amazon, but a few years ago you just really couldn't. You just had to buy them by 300ths at a time, and so. Ooh, it's.
Yeah.
Well, see if you can. Is that the lead?
No, sodium.
Okay. Well, that wouldn't be too bad. It's nice and soluble. You'll flush it out. The lead's not great for you.
Well,
Did
or
it
was
precipitate? We probably need it on a darker. Yeah, definitely a precipitate. If we put it on a nice dark surface, you can see that there is a precipitate in there. So, okay. So, next, here for Austin, we've got lead nitrate and sodium sulfate. So, lead sulfate. Consult your rules and see. We know the sodium nitrate's not going to precipitate, but what about lead sulfate?
Read Rule 5.
Rule 5. All sulfates are soluble except lead, strontium, and barium. So, looks like probably a precipitate. So, are there sulfates in here? I haven't seen one. Uh-oh.
What's that one?
Anyone see a dropper bottle that wandered off? I know I dropped a bunch of them, but... Well, I think we're going to have to go with the prediction here because lead sulfate is going to precipitate, but I don't seem to have a bottle of anything sulfate here at all. Well, if anyone happens to see a sulfate of any kind on the floor where I dropped it, we'll do it. What is that last one, though?
Zinc hydroxide, zinc 2 hydroxide plus sodium nitrate.
Okay. So zinc 2 hydroxide plus sodium nitrate.
Those are the products, though.
Oh, those are the products?
Yeah.
Okay. In a couple modules, you'll learn that everything can go back and forth in chemistry, so drawing the line the wrong way is alright. So that would have been
Zinc 2 nitrate plus sodium hydroxide with 2 in front of that. And then it would be a 2 in front of the sodium nitrate.
okay. So, what about these two products? So zinc hydroxide and sodium nitrate. We know sodium nitrate is going to be aqueous. So how about zinc hydroxide?
Hydroxides are insoluble, except for those polymer.
Okay, so we're going to go for a precipitate there. So I need zinc nitrate and sodium hydroxide. All right. So our last try here, probably going to get a precipitate. I still don't know about that copper. What was that we went? Copper iodide. I don't know. Contamination. It went in. It's good.
Is that enough?
Did it do anything?
Not really.
Put one more drop. Oh, well, put one more drop and then go wash your hands. What is it? It's zinc. It's alright. Not a strong base. Not bad. Actually, zinc's really good for you during cold season, but probably zinc hydroxide's not the way to go. Up, and then we put the right lids on, which is probably what happened down there last year. We probably put the wrong lids on. So Austin's going to wash his hands. Liam and I are going to use the black. Do you think that's cloudy or not cloudy?
This one?
Yes.
It's not really cloudy.
It's a little cloudy.
Well, it says the 6 wells that did not have a reaction. We had all of them that did have a reaction.
Yes. Well, let's put right next to it just clear. And when you put
Okay, yeah,
next to
you're
it
right.
clear, you can see
You're
that it's
right.
cloudy. It doesn't look compared to the really white ones, but if you just compare this clear one to that cloudy one, it's cloudier.
Yep.
So that can be, with just experience in the lab, you start to see like, oh, that's cloudy. No, it isn't. Yes, it is. A little bit cloudy. So you can pull your goggles off because the only things that we're going to have left for you three are making saltwater solutions, which if they get in your eye, is all right. Jenny, oh my goodness. What pair of goggles did you have on? That's horrible. Oh, man.
I'm gonna hide.
So, do we have any wells here where we did not observe a reaction? No, not really. So we
Definitely
think
not 6 of them.
no.
Yeah. Well, the copper iodide was supposed to be. What are we supposed to put in?
Did I pass out another sheet of paper to you guys? Or is there another side? This side? Okay, now here's what we're talking about. How many reactions did we do? Like 10?
Yeah.
Oh, we were supposed to do like 16. So, let's look at, if you look at the flip side here, there are some options that would not have had precipitates if I had been starting on the right page, we'd have seen. So here you guys can do a couple of those just so we can prove that not every double replacement reaction is a reaction. So, like Liam, if we do potassium iodide and zinc nitrate, I'm going to write just this one in black here. So potassium iodide plus zinc 2 nitrate, and that's going to give us zinc 2 iodide and potassium nitrate. And if we balance that,
Did you say it was zinc 2 nitrate?
it is. Zinc is always a 2. Is it balanced? Yes. Okay. So if we do zinc nitrate, this lead nitrate, that wouldn't work. Zinc nitrate and potassium iodide. And we don't get a contaminated well by some chance. Yeah, you put your goggles back on. Even though these guys are pretty safe, always wear them. Alright, so we should not observe a precipitate because if we consult the rules here, our two products, zinc iodide, which rule would apply to zinc iodide?
4.
Go ahead and do one more. So rule 4, all chlorides, bromides, and iodides are soluble, and zinc is not an exception. And then potassium nitrate, that would be rule 3, nitrates are soluble. So we shouldn't see, yeah. And do we see a reaction there? No, it's
Very
nice
hard to
and
tell
clear.
which one.
So, okay. Yes. Nice of them to make potassium iodide carry on the label. So if we did the other ones, you can see that one didn't form a precipitate, it's just all aqueous. So if we had done all of the mixtures that the first page called for, we would have found some, like that one, just do this. So, in this case, there was no chemical reaction. If you mix two things that are aqueous solutions together and all of them are soluble in water in any combination, they just stay dissolved. So this arrow isn't true. There's no reaction there. For all the ones that we did before, we did see precipitates form, and that means a chemical reaction occurred. So solution chemistry can be important because if there's, if everything stays dissolved, there's just no chemical reaction. You can mix things all day long and they just stay dissolved.
This
But-
isn't in the book.
Not necessarily, but it does tell you do Microchem 5 somewhere in the chapter if you want. It's really hard if somebody doesn't tell you what is going on in Microchem 5 to figure out what that is. So here it says for those 6 wells that we didn't do all of, that did not have a reaction, why was there no reaction? So what should we write there in number 2? So the ones like potassium iodide and zinc nitrate, where we saw no reaction, why was there no reaction?
Because both of the reactants were soluble,
And
that meant that there was no chemical reaction.
both of the products were also soluble, I think is what you're trying to say. Because in every case, the reactants were all soluble, all aqueous reactants, right? So these guys are, all the reactants are soluble, but when the products are also soluble, there's no reaction. So in number 2, I would write when both reactants and both products are soluble, there's no reaction. Or I guess both possible reactants. Or- This is number 2 on the sheet we've been using. So it says, for the 6 wells that did not have a reaction, why not? Write down the 2 chemicals that were added together in these 6 wells, which we're not doing, we don't have time. But that would be an example. It gives you another example. So potassium iodide plus zinc nitrate gives you 2 things that are soluble. So there's no reaction because they all just remain dissolved. Hopefully everyone's got this part down. So I'm going to erase what's below that and write the answer to number 2 on the board. Okay. So that's what I would write for 2. It gives this example.